Now we are going to create a slightly more complex behaviour using visual scripting. So now within the scene we have the pitcher being able to throw the ball towards the batter, but at the moment the batter can't bat the ball back. So this is what we're going to work on now. So we still want to work within the baseball, because it's when the baseball is hit that the actual behaviour for the baseball will happen. It's not actually the batter. The batter might trigger this to happen, but it's actually the baseball in which the behaviour occurs upon. So to start off with, we need another apply force from the task library. So if you don't already have this open, reload the library, search for apply force and choose physics apply force. Pull this into the graph, so drag and drop it into the graph. Have a quick look at its attributes. So basically the subject is the graph owner, which is the baseball, which is fine because that's what we need. And the force being applied is not right here, so it's 0, 1, 0. So we need it to be, for a force to be able to hit the ball back towards the pitcher, we need 40, 70, minus 40. So that's positive 40 for the x-axis, positive 70 for the y-axis, and minus 40 for the z-axis. So okay, so if we just attach this to on hit, so when the ball is hit, apply this force. Okay, so I think we can go ahead and run that. So in order to test this, what we're going to have to do is we're going to have the pitcher throw the ball by using the behaviour already created, and then stimulate the apply force on the ball in order to see what happens within the scene. So if we start by running the scene, first of all the ball will drop down. Okay, we'll change our view so we have a good view of where the ball is being thrown. So we first of all stimulate the ball being thrown. Okay, so that's working. So let's do that again, and this time we're going to simulate the ball being hit. So you might have noticed then the ball's been hit, but it's ended up behind the batter. This is just an artifact of the fact that the scene has physics within, because the ball is realistically simulated wherever the force is applied on the ball. So when the ball is being thrown to the batter, there's going to be some curve involved, and it all depends on where within that curve the new force is applied. That depends on where the ball will go within the actual scene itself. So what we need to do now then is, we don't realistically want the same force being applied to the ball, because that doesn't realistically make a good simulation. So what we also want to add to this is a slightly more complex behaviour where we will randomise the force which is applied to the ball. So in order to do this, what we're going to need is a vector. So we're going to need a vector which is basically the force, which is the same as here. It's a 3D vector, which is going to be the force which is going to be applied on the ball. But because we don't have lower access to each of the individual axes here, then we need to be able to do this in a different way. So let's just search in the task library and find a float to vec3. So float to a 3D vector. So we'll drop that within the scene. Now we have access to the x, y and z parts of the vector itself, the force that we're going to apply. So the vector itself is going to become the force. We can also remove this connection from the event. So now we can connect this done pin to that start pin. So basically once this new float has been created, this new vector has been created, we apply the force using that vector. Then what we want to do is we need to find some random. So we want some randomization to this. It's not going to be a realistic simulation. We're not making an actual realistic simulation, but it'd be nice if there was some random behavior to the ball. So we choose math random. So again, task library. If there's nothing in the task library, reload the library, type in random, choose math random, drop that onto the scene, onto the graph, sorry. So what we want to do is we want to have 3 of these, so we randomize each of these different parts of the vector. So the x, y and z axes of the vector. So we will drop 3 of these onto the graph. Then what we will do is choose the first one that is at the top, so we can treat that as X. So we will click on that, and then what we will do is we will set the maximum, so the maximum random number will be 150 and the minimum random number will be 30. So for X, we'll connect the result, so this is the result of whatever random number is selected between 30 and 150, and that is fed in to become the x-axis of the 3D vector. Then we can repeat the same action with the other random tasks. So in this one we will have a minimum of 30, but we'll leave the maximum as 100. And then we'll do the same for the Z. We'll do 150 on this one now, and minimum of 30. Okay. Now, before we connect each of these, the y-axis is fine. We can connect that to there. But before we connect the z-axis, you might remember that when we applied the force, the z-axis was actually negative. So this random number is going to become a positive. So what we need to do is again search through the task library and find multiply. So math multiply. This will allow you to multiply any type of number. So it could be a real number, a float, a vector, and it'll allow you to multiply it. So we'll add that there. And then what we want to do is multiply the input, which is going to be the z-axis, and then we're going to multiply that by -1. So we're going to basically multiply whatever comes out of this random by -1 in order to get the negative value for the z. So then we connect the result of that to the z-axis of the vector, the z input. Okay, so now what we can do is we can just start connecting everything. So once we've done with this random, move on to the next random, move on to the next random. Once the next random is done, multiply it, and then once all the calculations are done, because by this point we've done this, we've done this, we've come down here and done this, we've done the multiply to make z a negative number, and then we can start the creation of the vector, and then on to applying the force based on that vector. So now, as you can see, we have a random force being applied back to the ball. So what we should also do at this point is connect the beginning, so the very first random we will connect to the onHit event. So now, if we've left this running while we've been doing this, but if we just double click so the pitcher throws the ball, and then, oh, it wasn't quick enough, double click so the pitcher throws the ball, and then double click on hit to hit it back. So there we go. So you will notice now though that although this time the ball has been hit to just behind where the pitcher is, if we were to do it again, there's some randomness, you know, that's not the same place. So this is what creates a more sort of realistic simulation, and because of the fact that the ball you know, has the simulate physics enabled and the pitch has the collide only enabled, and the ball's allowed to react naturally to the pitch, and creates a nice simulation. In this tutorial we have shown you how to create a complex behaviour using visual scripting.